For a problem like this, we want to actually first factor the denominator. We notice here that there is a common factor in each of those. We want to pull that out first because that's going to help us to determine what that least common denominator is going to have to be once we see them all factored. So that's the first step. We could begin by factoring out a 4. So we get 4 times, it's going to be x plus 3. This next one doesn't need to be factored. And then this one, once again, we'll factor out a 4 and get the same thing, 4 times x plus 3. Now we know by looking at this that x plus 3 needs to be part of our least common denominator as well as 4. So I'm going to multiply all of these by 4 times x plus 3 over 1. So 4 times x plus 3 over 1 will get multiplied by the first fraction we see here. And we will also put that next to the other fraction. And then we'll put it next to this last fraction. Okay, so now we've put that least common denominator in front of each fraction. What we want to do is start to reduce. So 4 times x plus 3, this whole thing is going to cancel with this whole thing on the bottom. It also happens with this last term as well. So we can cancel those out completely. But this middle term that we have, x plus 3 will cancel out with x plus 3. So now that all that's canceled, let's rewrite it. We have x equals, this will be 4. We still have a 4 there. So it's 4 times 3x minus 8. Then we have minus 3x since everything else canceled out. So now we're going to multiply by the 4. We get 12x minus 32. And we have minus 3x. We want to add the like terms here, so I'll do that up here. So I have x equals 12x minus the 3x that we have here is going to be a 9x. And then I have minus 32 still. Next, we're going to subtract 9x from both sides. And we get negative 8x equals negative 32. We'll divide both sides by negative 8. And we're going to get a positive 4 as a result since the negatives cancel here. Now 4 does not cause division by 0, which means this will be our answer, x equals 4. Now you're not always going to get an integer answer like this. This one next that we're going to do is one that has a fraction as a result, but you're still going to solve it exactly the same way. We have some common factors we can factor out of the denominators here. So we'll start by factoring out a 3, and we get x plus 3 there. This next one doesn't need any factoring. And this one on the end here, once again, we can factor that out, and we get 3 times x plus 3. All right, so now that we have that, we're going to now, and this is a minus here, not a plus. That look, the minus. We're going to multiply everything by 3 times x plus 3 over 1. So I'm going to put this, like I did before in the previous problem, I'm putting this over 1 in front of each fraction that I have. So a question that often comes up with this is, do I have to write all of it out? Do I have to put all of it in front? And my answer is yes, it's highly suggested that you do so, because if you don't write all this out, you may not see what's going to cancel and you might miss something. So although it takes a little bit to write all this out, you do want to do that so that way you don't miss something. And all the things that you need to cancel will cancel because you can visually see what you're going to cancel here. Like for instance, these are going to cancel here. The 3 times x plus 3, they also cancel out here as well. All we have left is an x. This one, x plus 3 will cancel, and you're going to have a 3 times 3x minus 14. Then you have minus 3x. We'll multiply by 3. We'll get 9x minus 42. And we still want to simplify this like before. So 9x minus 3x is 6x. We're going to subtract 6x from both sides. So you have 1 minus 6 is negative 5x equals negative 42. And then now we just need to divide both sides by negative 5. And as you see there, we do in fact get a fraction here because 5 doesn't divide into 42. That would be fully reduced. And so that's all you need to do. So again, not always will you get integer answers. It's possible you might get fractional answers as well.